Welcome everyone! Across universities and research labs, artificial intelligence is now assisting with experiments, analyzing complex data, and even generating new theories. In just the past 2 years, large language models and scientific reasoning engines have started performing tasks once reserved for PhDs. With this rapid pace of development, many are now asking a bold question. Could AI replace academic researchers entirely by 2028? One of the most widely used systems is Elicit. This platform allows researchers to ask complex scientific questions and instantly receive a curated list of relevant studies. Instead of spending hours searching through journals, scientists can now get literature reviews in seconds. Elicit uses AI to extract the core findings from each paper and organizes them by strength of evidence. It is like having a superpowered research assistant who never sleeps. Another fast-growing tool is Semantic Scholar. This AI platform, backed by the Allen Institute for AI, uses natural language understanding to recommend related papers, identify influential citations, and rank scientific results by impact. Researchers using Semantic Scholar can quickly find hidden connections between studies, making it easier to build new theories on top of existing work. AutoML systems are also making their way into research labs. These AI tools can automatically select the best statistical models for a dataset, tune the parameters, and even generate performance reports. In academic fields that rely on machine learning, these tools remove the need for extensive programming. The researcher can focus on asking the right questions while the AI handles the technical setup. In biology, DeepMind's AlphaFold shocked the world by predicting the structure of nearly every known protein. This achievement had stumped human researchers for decades. Now, with just a few lines of code, scientists can access these protein models and build on them in their own studies. What used to take years of lab work can now happen in just minutes on a computer. Laboratory automation is also growing fast. Robotic systems powered by AI can run entire sequences of experiments without human supervision. These systems can test thousands of samples, change variables, and report results while learning from each cycle. Known as self-driving labs, they're already being used in material science and drug discovery. In some cases, AI is going beyond just assisting humans. Projects like Galactica and Cybert attempt to generate scientific text directly from raw data or experimental summaries. While still early in development, these models can already write abstracts, suggest conclusions, and even simulate discussions between imaginary researchers. The line between human authorship and machine assistance is definitely becoming blurred. The peer review process is also starting to use AI. Journals and conferences now use automated systems to screen submissions for plagiarism, flawed statistics, and formatting issues. Some systems can even evaluate the novelty of a submission based on prior literature. These tools are improving the speed and reliability of scientific publishing. Language models are helping non-native English speakers participate more fully in global research. Platforms like Writeful and Grammarly use AI to refine grammar, clarity, and academic tone. For many scientists around the world, these tools act as invisible editors, allowing ideas to be judged on merit rather than writing style. AI is even entering the realm of hypothesis generation. IBM Research has developed a system called Project Debater that can scan the entire scientific literature and generate novel hypotheses based on gaps and contradictions in existing work. While not yet mainstream, these tools are testing the idea that machines can contribute to the frontiers of thought rather than just support it. Scientific publishing itself is becoming more machine-assisted. Some publishers now use AI tools to recommend suitable journals for submission, detect conflicts of interest, and even suggest potential peer reviewers. These systems analyze the topic, style, and references of a paper to find the best fit. This is cutting down the time between submission and publication and giving younger researchers a better chance of reaching the right audience. In chemistry, AI is already being used to predict reactions that have never been tried before. Researchers are feeding enormous data sets of known reactions into neural networks, which then suggest new combinations of molecules that might produce valuable compounds. This method is especially powerful in drug discovery, where thousands of possible variations can be tested in virtual space before a single experiment is run in a lab. Physics and astronomy are also being transformed. Machine learning algorithms now sift through massive volumes of telescope data to find rare patterns that human eyes might miss. This includes detecting new exoplanets, identifying gravitational wave signals, and modeling the structure of galaxies. What would take humans decades of analysis can now be done in days with AI tools trained on real observations. In social science, AI is unlocking new methods for studying human behavior. Systems are now analyzing video footage, survey data, and digital communication to detect trends and relationships that were previously invisible. These AI-driven studies are helping researchers understand how opinions form, how groups behave, and how information spreads through online communities. The results are already influencing public policy and education strategies. Perhaps most surprising is how AI is helping to uncover errors in past research. Retrospective analysis tools can scan hundreds of published papers and flag statistical mistakes, duplicated results, or suspicious data patterns. This kind of large-scale review was impossible before. It is becoming a safeguard that improves the integrity of the scientific record. As AI continues to advance, the definition of a researcher may begin to shift. Instead of spending years mastering every tool, future scientists might focus on guiding intelligent systems, framing important questions, and interpreting results. The creative and ethical aspects of discovery could become more central, while the repetitive tasks are handled by machines. This raises some really important questions about authorship and credit. If an AI comes up with the hypothesis, designs the experiment, and even analyzes the results, who actually gets to be called the author of the paper? Will institutions start giving digital contributors their own kind of recognition in scientific databases? These sorts of questions are already sparking debates in academic circles, and new standards might be just around the corner. The training of new scientists could also change dramatically. Instead of learning programming and statistical techniques from scratch, students may be taught how to work with AI tools from the beginning. Research education might become more about collaboration and strategy, less about manual methods. A new generation of researchers will grow up with these systems as their everyday partners. Some experts believe that AI could eventually pursue research independently. Given access to data, computation, and goals, a sufficiently advanced system might propose lines of inquiry that no human has imagined. It could even detect patterns that humans are incapable of seeing due to cognitive limits. Whether this would qualify as true intelligence or just deep automation is still up for debate. In the next few years, we will likely see a growing blend of human and machine research. AI will not replace all scientists, but it will change what they do and how they do it. By 2028, many labs may depend more on AI than on postdoctoral staff. This shift could democratize science, accelerate breakthroughs, and redefine what it means to explore the unknown. Thank you very much for watching. Please like and subscribe. Whether AI replaces researchers or simply transforms how science is done, one thing is clear. The role of human curiosity is evolving. Academic discovery may no longer belong only to humans. By 2028, machines could be contributing more than we ever imagined, challenging what it means to think, to learn, and to know.